Our third lesson in Unit 2 is going to deal with applying parallel lines to demonstrate and prove the triangle angle sum theorem, that the sum of the measures of the angles in a triangle is 180 degrees. Along the way, we're using the interior angles of the triangle. That's typically where we focus. But we're also going to talk about exterior angles for all polygons, but specifically in this context, exterior angles for triangles. And so we'll define what those are and we will move from there. So here's just a little review. This is some quick, easy vocabulary. Classifying triangles by their angles and also classifying triangles by their sides and how they relate to one another. So an equiangular triangle is one where all the angles are the same measure. An acute triangle, all the angles are less than 90 degrees. A right triangle has a right angle. An obtuse triangle has an obtuse angle. An equilateral triangle has all sides that are congruent, whereas an isosceles triangle only has two sides congruent. An equilateral triangle is a type of isosceles triangle. And then there's scalene triangles, which is what we typically draw, and that is a triangle where none of the sides are congruent to each other, and therefore none of the angles are congruent. All right, so this first fun fact, Theorem 210, states that through any point in space and given a line, we can draw a line through that point that is parallel to another line in space. So think about in Algebra 1, they would say, given this equation of the line, y equals mx plus b, and this point, x comma y, find the equation of the line that goes through that point that is parallel to that line, and we would find the answer, right? We would determine, oh, these parallel lines have the same slope, and then we would use y minus y1 equals m times x minus x1 to find the equation in y equals mx plus b form of the line that passes through that point and is parallel to the other line. So we understand that that's true in algebra class, and we are still going to apply that here in geometry. And there's different ways to approach proving that. I'm not really concerned with that at this point. What I am concerned with is applying that concept so that we can outline the fact that the sum of the measures of the interior angles of a triangle is 180 degrees. And here's how we're going to model that. If I were to draw a line through point C that is parallel to line AB, so that I get parallel lines, parallel to line AB, but through point C, I would be able to show that the angle at A is congruent to this angle by C, and this angle at B is congruent to this angle at C. All right, those are alternate interior angles, so they're congruent. These are alternate interior angles, so they're congruent. And then this is the angle at C. So all three of these angles, by the angle addition postulate, together make a straight angle, and so their measures sum to 180 degrees. Therefore, the angles in the triangle, A, B, and C, also add up to 180 degrees. This is just a proof of that concept that you already believed and understood from previous courses, I'm assuming. And so that is going to explain what most of our work is going to look like in class and in our notes today. We're going to focus on, if I know the measures of two angles, can I find the measure of the third angle? It's basically some simple addition and subtraction. However, there's a lot of places where we can make mistakes, and so we want to avoid making mistakes. We're going to try some exercises and try to make sure that we can find the measures of the unknown angles, so that we can so we can apply the fact that the sum of the measures of these angles is equal to 180 degrees. So the measure of angle 1 plus 40 degrees plus 85 degrees is going to add up to 180 degrees. I've got the degrees because we know we're talking about degrees here. I can simplify these by combining my like terms. And then I can use APOE to subtract 125 or add negative 125 to both sides. And that will tell us that the measure of angle 1 is 55. Creating the equation, again, is up to us. We're not given the equation, we're given the diagram. But we know that the sum of the measures of the angles in a triangle is 180 degrees. And then we can solve the equation using mental math, calculator math, etc. We're going to do a lot of exercises with that in our classwork. Exterior angles and remote interior angles. In this diagram, these are all interior angles. So what are exterior angles? Well, an exterior angle is an angle that's formed by a side of a polygon. Oh, this is the bad marker. By the side of a polygon and the extension of an adjacent side. All right? So this is the side, and then this is an extension of that adjacent side, and that creates this exterior angle. It's on the outside of the triangle. It's not the whole way around. It's basically the supplement of, or making a linear pair with, that interior angle at that vertex. Now we could draw multiple, really two, we can draw two exterior angles at each vertex. So if I use this side and I extend that side, I have this exterior angle that is supplementary to angle 3. Likewise, I could use, likewise I could use this side here and I could extend that side, and this would be an exterior angle because it is supplementary to angle 3. It's the extension of this side and that side. This right here is not an exterior angle. That is not an exterior angle. Yes, it is outside of the triangle, but it is vertical angle with that interior angle, so it's not supplementary to that interior angle. It doesn't fit the definition. It's formed by two extensions of a side, but no actual sides of the triangle. So it doesn't fit the definition. We have to go by what the definition is. All right, now the remote interior angles of a triangle would be, if this is our exterior angle, and this is interior, great. These other two are the remote. Remote means like far away. These are the remote interior angles. Remote interior angles are angles 3 and 4. So we've got angle 1 is exterior. The adjacent interior is angle 2. But then the remote interior angles are 3 and 4. All right? Now again, the numbers of those angles doesn't matter. It's all about position. Where are they in relation to the exterior angle that we are talking about or discussing in the question, in the exercise, in the diagram, etc. And here's the fun fact. The measure of the exterior angle of a triangle is equal to the sum of the measures of those two remote interior angles. The proof on this is, not too terribly difficult. Essentially what we know is that the measure of angle 1 and the measure of angle 2 is 180. We know that the measure of angle 3 and the measure of angle 4 and the measure of angle 2, all of those together add up to 180. And so if I, from both of those situations, subtracted the measure of angle 2, subtracted the measure of angle 2, from this side of the equation and from this side of the equation in both equations, that's going to give me this statement that the measure of angle 1 is equal to 180 minus the measure of angle 2, which is also equal to the measure of angle 3 and the measure of angle 4. So if these two things are equal to the same thing, then those two things are equal to each other, either by the transitive property, or we could use substitution property in there as another way to show that, transitive POE or substitution POE. So that shows us that this measure is equal to this sum, the sum of those measures. That proof, again, isn't hopefully too large of a leap of logic, but we can use this information where if I know these two angles, and I can find this one or that one. If I know this one, I can figure out what those two add up to. There's lots of different ways in which we can apply that, and it's just a different way to get that information or to apply that information. So the measure of angle 1 here, instead of using these to find that and then using this to find that, I can go straight from the fact that measure of angle 1 is equal to the sum of the remote interior angles. And so I can add those together to get 140. The measure of angle 1 is equal to 65 plus 75, 140 degrees. Over here, 80 is the exterior angle, and then 34 and the measure of angle 2, 34 and angle 2 are the interior, the remote interior angles. And so I can write this equation that the exterior angle is the sum of the measures of the remote interior angles. I can subtract 34 to find out that the measure of angle 2 is 46. Again, create your equation so that you can solve your equation. I can write this equation because of the exterior angle theorem, and then I can solve it using simplifying. I can write this equation using the using the exterior angle theorem for triangles, and I can solve that by using APOE. So that is the goal for this work. It seems pretty straightforward. It seems pretty easy. Don't take that for granted. Use a calculator in all of your subtraction.